Welcome to The Explainer. Today, we're getting under the hood of hybrid vehicles. We're going to break down the amazing engineering that takes them from the car you see every day all the way to the cutting-edge drones flying high above us. Okay, let's just dive right in. For the longest time, designing a car was all about this one big trade-off. On one hand, you have the gasoline engine. Tons of power, great range. On the other, the electric motor. Super quiet, efficient, and zero emissions. It always felt like you had to pick one. But then, someone asked this simple but revolutionary question. What if you could stop compromising? What if you could find a way to get the best of both worlds, all in one vehicle? That question really kicked off an entire engineering movement. And that right there is the heart of what a hybrid is. It's this brilliant combination, this sophisticated dance between a gas engine and an electric motor. The whole idea is to let each part do what it does best, using their strengths to cover for each other's weaknesses. So how do you actually do it? How do you combine an engine and a motor? Well, it turns out there's not just one way to do it. Engineers have come up with three main recipes, you could call them, or architectures, that control how all that power gets to the wheels. First up, we've got the series hybrid. This is the most straightforward setup. Honestly, the best way to think about it is like an electric car that just happens to bring its own power plant along for the ride. And look at this. The gas engine has absolutely no physical connection to the wheels. That's the really clever part. It means the engine can just hum along at its one single most efficient speed, its happy place, and just generate electricity. It doesn't care if you're going 5 miles an hour or 50. So this setup is absolutely fantastic for city driving. All that stop-and-go traffic is handled perfectly by the instant torque of the electric motor. The downside, though, it comes on the highway. You actually lose some energy, converting power from mechanical to electrical and back again, which makes it a little less efficient at high constant speeds. All right, let's move on to our next recipe, the parallel hybrid. Now, this one works on a totally different principle. Here, both the engine and the motor are connected directly to the drivetrain. This analogy of a tandem bike is just perfect. It shows you the flexibility, right? The engine can power the car, the motor can power the car, or, and this is the cool part, they can both work together, combining their power when you really need to accelerate. Because of that flexibility, these are great for highway driving and dynamic situations. But there's always a trade-off, isn't there? It's mechanically a lot more complex. And the engine, well, it has to rev up and down with the car's speed, so it can't always stay in that perfect, efficient sweet spot like a series hybrid can. And finally, we get to the most advanced and probably the most common architecture you see today. This is the one that cars like the Toyota Prius made famous. It's the series parallel hybrid, often called a power split system. This really is the best of both worlds approach. The magic here is a little device called a planetary gear set. It's an incredible piece of engineering that lets a computer continuously blend the power sources. It can act like a series hybrid in the city, a parallel on the highway, or anything in between, constantly optimizing for the best possible efficiency. The result? Maximum efficiency pretty much everywhere you drive. So what's the catch? Well, all that genius comes with the highest level of mechanical and software complexity. And you guessed it, that makes it the most expensive to build. Okay, so we've covered the three main layouts. But now let's look at this from a totally different angle. Because it's not just about how the parts are connected, it's also about the degree of hybridization. How much does the electric side of things actually do? You can really think of it as a spectrum. On one end, you have mild hybrids, which basically just give the engine a little electric boost. In the middle, you have full hybrids. These can actually drive for short distances on electricity alone. And then, way over on the far end, you have plug-in hybrids, which bring the power grid itself into the equation. And you can see the relationship pretty clearly here. The main takeaway is that as the battery gets bigger, the car's ability to run on pure electricity goes up. It all leads to the plug-in hybrid, whose large battery can be charged from a wall outlet, giving you a serious amount of gas-free driving, often more than enough for a whole day's commute. So far, we've pretty much kept our feet on the ground talking about cars. But now we're going to take this whole conversation to a much, much higher altitude, because these same principles are starting a revolution somewhere else entirely. That's right. That same brilliant compromise, combining an engine's endurance with a motor's quiet efficiency, is now being applied to aviation. We're talking everything from unmanned drones to urban air taxis and maybe even the commercial jets of the future. But here's the interesting thing. The goals in the air are a little bit different. With cars, it's all about getting better miles per gallon in traffic. With aircraft, hybrid systems are used for other critical things, like flying farther, being much quieter, and helping the engine perform better in the thin air at high altitudes. And for drones, both military and commercial, this is an absolute game changer. It means they can fly much longer surveillance missions. It gives them a backup if one power system fails, which is huge for safety. And it even allows for a silent mode, letting a drone switch to just its battery for a stealthy, quiet approach. So, after all this, what does it all mean for the future of transportation, on the ground and in the air? Where does all this hybrid tech really fit in? And this is probably the most important thing to get. The hybrid isn't just some temporary bridge on the way to fully electric vehicles. For a lot of uses, especially things like aviation or heavy transport, it's a powerful and permanent solution. It solves engineering problems that pure battery power just can't handle yet. Think about it. Everything we've learned from over 20 years of developing hybrids, the power electronics, the regenerative braking, the complex software that makes it all work together, that knowledge is the very foundation that the future of mobility is being built on. Which leaves us with one last really fascinating question to think about. This technology has proven itself on our roads and in our skies. So, what's next? Heavy-duty trucks? Massive cargo ships? The hybrid revolution, it seems, is really just getting started. Thanks for joining this explainer.